Hello and welcome to another lesson from Soflex Math. Today we're going to be working on our third type of dividing fractions, which is a mixed number divided by a regular old proper fraction. So we're going to kind of follow some of the same rules that we did with mixed numbers, turning them into improper fractions, and then following the steps that we have for division as far as changing the sign and using the reciprocal or flipping the second number. All right, so with these, we have a different first step. Our first step for these is going to be to turn this number right here, this mixed number, into an improper fraction to start. So we're going to do that by going 3 times 4 is 12 plus 1 is 13. So we're going to rewrite our mixed number as an equivalent improper fraction. Then we're going to change our sign to multiplying. So we're building our new problem here, and then we're going to flip our second number to make that 4 over 3. All right, then we check to see there. In this case, there's nothing to cross cancel or simplify, so we're just going to have to go ahead and do our multiplication. So we'll start with the denominators. That's easy. 3 times 3 is 9. Okay, 13 times 4. So 4 times 3 is 12. Carry the 1 in your head. 4 times 1 is 4 plus 1 is 5. So we end up with an answer of 52/9. And as we know, that is not simplest form. We need to have a mixed number. So we kind of say how many 9s go into 52. So we could say 4, nope, 5, nope, 6, too much. So we're going to have to go back to 5. So 9 times 5 is 45. 45 plus 7 is 52. So there we go. So 5 7/9 is our simplified mixed number answer. 52/9 is our unsimplified or improper fraction answer, but we want to do and use the one that is circled. All right, so let's try. We have 3 more examples to walk through here. All right, so think to yourself, step 1 is what? Answer that to yourself, and hopefully your answer 1 was to make this an improper fraction. So 4 times 7 is 28 plus 1 is 29. All right, change the sign is step 2. Use the reciprocal, which means flip it over, is step 3. All right, once again, these numbers are not too friendly. So 4 times 3 is friendly. We can make that a 12. 29 times 5, maybe not so much. So if you can't do 29 times 5 in your head, you can either make a little problem or just visualize it in your head. 5 times 9 is 45, so we write down the 5, carry the little 4. 5 times 2 is 10, plus 4 is 145. So this is our improper answer. All right. If you're good at your multiplication facts through 12, you probably know that 12 times the 12 is 144, and then 1 left over would be 145. If you didn't memorize your 12s yet, that's okay. Then you're just going to have to set up your double-digit division problem. All right, and you're going to say how many 12s can go into 14? 1. Subtract, bring down. How many 12s can go into 25? 2. 24. Subtract. Running out of space here. Remainder 1. So either way, you're going to be able to either do that in your head, or you can do it as a little miniature division problem. Either way, your final answer for this one is 12 and 1/12. And once again, with those examples, notice how your answer is getting greater or bigger. We started with basically a 7, and we're ending up with basically a 12. Same thing with that first example. All right, let's go ahead and try 2 more. All right, this time we have 6 2/3 divided by 1/8. So let's go ahead and make an improper fraction. 3 times 6 plus 2. So 3 times 6 is 18 plus 2 is 20 over 3. Once again, change the sign to multiply. Flip our second number. Once again, nothing to simplify. So now we got the power of 0, remember? So 8 times 2 is 16 plus a 0. 3 times 1, pretty simple, 3. All right. Notice all our answers are starting off as improper fractions, but we're going to have to switch these all over. So let's go ahead and divide that one out for you. So 3 into 16, I think about 5 times, which would get us a 15. bring down. Now we have a 10. How many 3's can go into 10? 3, which is 9. Subtract remainder 1. And then we just got to put that back together. So we have 53, and then remainder 1, numerator, and denominator divisor stays the same. So 53 and 1/3 is your answer to that example. All right, one last one to try together. So I would suggest maybe if you want, hit pause on the video here, and then I'd like you to try this one on your own as if it were an assignment or a quiz, and then I'm going to walk my way through it. So if you'd like to, pause now, otherwise I'm going to keep working on the solution. All right, so hopefully if you worked on it on your own, you can compare what you've done to our answers here. So denominator is still a 2. 8 times 2 is 16, plus 1 is 17. Change our sign to multiply, and flip our numbers. 5/7 becomes 7/5. Remember, that is called a reciprocal. Denominator is always easy here. We can multiply those and get a 10. All right, 17 times 7. So 7 times 7 is 49. Carry the 4. 7 times 1 is 7, plus 4 is 11. All right. We got to change our improper answer to a mixed number. So how many 10s can go into 119? So we can either count by 10s, 10, 20, 30, and so on, or we could just say maybe 11, because 11 times 10 is 110, with 9 left over. If you were unable to, once again, to do that in your head, we can make our little problem here. 110 goes into 11. Okay. And then 110 can go into 19. So our remainder is 9. So there we go. 11, remainder 9. Denominator is the same. 11, remainder 9. Divisor is the same. So hopefully these dividing mixed numbers by fractions is a little bit easier for you. Our final lesson coming up next will be dividing a mixed number by a mixed number. But go ahead and practice on your own, see how you do. Our goal always is 80%, and we'll see you in our next lesson of Soflex Math.